Today we'll be working on graphing quadratics in vertex form and in root form. But before we do that, let's explore the parent quadratic function. Y equals x to the power 2. Now, before we can decide what the intercepts are, the axis of symmetry, the vertex, and all of that, let's go ahead and graph it. To do that, let's plug in certain values for x. So if x is -3, plug in -3 to the power 2. So basically it's going to be like that. Anything to the power 2 would become a positive, so that's going to be a 9. If you plug in -2, -2 to the power 2 is 4, -1 to the power 2 is 1, 0 to the power 2 is 0, 1 to the power 2 is 1, 2 to the power 2 is 4, and 3 to the power 2 is 9. Now take a minute and plot these points. Now after you plot them, let's go ahead and connect the points. As you can see, it's a U shape having a vertex at the origin. So this is going to be my vertex. And if you take a closer look at the table, you'll see that everything is symmetrical around the vertex. And that will help us come up with a pattern to be able to graph quadratic functions. So let's see what the pattern is. From 0 to 1, I'm adding a 1. Now from 1 to 4, I'm going up 3. And then from 4 to 9, I'm going up how much? 5. So every single time I have a quadratic function, once I know what the vertex is, I know then the pattern is going to be 1, 3, 5, 7, and so on. So all the odd numbers. And this is the case if a is equal to 1. The a is the number or the coefficient of x to the power 2. What happens if the a is not 1? We'll talk about that later. So this is a pattern I can use every time I want to graph a quadratic function. If a is 1, I can tell what the vertex is, and then I can go up 1, always over 1, and then up 3 over 1, up 5 over 1. So 1, 3, 5. Now let's go ahead and take a closer look at this parabola. What's my y-intercept? In this case, the y-intercept is at the same time the x-intercept, which is the vertex. The root and the 0 mean the same thing, and basically, in this case, it's x equals 0. What's the solution? It means if you plug in x equals 0, you're going to get y to be equal to 0. The axis of symmetry is going to be the line that cuts this parabola in half. And in this case, it's a vertical line going through the vertex. So the equation of this line is going to be always x equals the x of the vertex. In this case, it's x equals 0. Now, as you can see, this vertex is a minimum. So every time it opens upward, the vertex is a minimum at 0. The domain, as you can see, this is going on forever to the left and to the right. So my domain is going to be -infinity to +infinity. The range is going to be from bottom to top. So the lowest point is going to be 0 all the way up to +infinity. Now, what are the 3 other names for x-intercepts? What do you think? Solution, 0, root. They all mean the same thing. Now, what is the name of the point where the y value of the function changes direction? Let's look. Now, if you just take the vertex, let's look at the left side of the vertex. This is a decreasing function, and then we have the vertex, and then it's an increasing function. So the vertex is the point where the y value of the function changes direction. It means it goes from either increasing function to a decreasing function, or a decreasing function to increasing function. So it's basically changing direction. So here it's decreasing, we have the vertex, and then increasing. So the vertex is this point. And that's the parent function. Now, let's go ahead and look at the general form of a vertex form and a factored form, which is another name for root form. So basically, they mean the same thing. Now, every time I have a vertex form, your quadratic equation is going to be in the form y equals a, x minus h to the power 2 plus k. This reminds us of the absolute value function, y equals a, x minus h plus k. Now, in the vertex form, we had 1 over b. In the quadratic function, we're not going to discuss that. But the vertex is always going to be hk. You always take the opposite of the number on the inside and the k. And that's going to tell you how your graph is moving, whether left, right, up, down, and so on. In this case, the vertex is the same thing. It's h, comma, k. How does a affect my graph? Just like we talked before, if a is positive, then my graph is opening upward. It's a U shape, not a V shape anymore, since this is quadratic function. And if a is negative, then it's going to be going down. Now, how do you find x-intercept? It's going to be where the graph touches the x-axis. How do you find the y-intercept? It's where the graph touches the y-axis. Now, how do we do that algebraically? We're also going to talk about these as we're graphing. Now, the factored form. Why is it called a factored form or a root form? Because you can get the roots from the equation. You can always take the opposite of these numbers on the inside, and these will be your two roots. How do you find the vertex? This is going to be something we will discuss as we graph. Now, this is everything you need to know about the parent function, vertex form for now, and the factored form. Now, let's do the other part of our notes. And let's take a closer look at one of the questions. Now, this is, as you can see, a vertex form. So I can find the vertex from this equation. The a in this case is the number in front, which is 2. H is going to be the opposite of the number on the inside, which is 5. And k is going to be negative 8. So my vertex is 5, negative 8. Now, since the a is positive, this is going to be a function opening upward. In this case, the vertex is going to be the lowest point, so that's going to be called a minimum. Now, let's go ahead and plot the vertex. So that's my vertex, and I know that my graph will open upward. Now, we do have a pattern that we need to follow. But before we know what the pattern is, let's go ahead and plug in some points. I'm going to start with my vertex, and I'm going to put it in the middle. And I'm going to take a number on the left side of the vertex and a number on the right side of the vertex. Now plug in 4 in your equation and find what the y value is. Now, I do hope you all found the number to be a negative 6. Now plug in 6 in the equation, and let's see what y value we'll get. So 6 minus 5 is 1. 1 to the power 2 is just 1. 2 times 1 is a 2. Minus 8 is a 6, or negative 6. So let's plot these 2 points. Now, this is not going to be enough, so you need more points. So go ahead and plot as many points as you can to have a better looking parabola. Maybe plug in 3 and then plug in 7 in your equation. Plug in then maybe 2 and then plug in 8 in your equation. So basically a number on the left side of the vertex and then to the right side. So plug in 3 and 2, 7 and 8, and find what the numbers are. Yes, there's a pattern, but let's plug in the points now until we find the pattern. So once you find the points, go ahead and plot them. Once you're done with that, connect the parabola And as you can see, it's a parabola opening upward, but we already know that since the A is positive, it has a minimum because the vertex is the lowest point of this graph. So let's try to find the pattern. From the vertex, let's count together. Now, if you remember that the parent function, the pattern was 1, 3, 5. Now, let's see what the pattern is from the vertex. I'm counting upward 2 over 1, so we counted up 2. And then from that point, let's count 1, 2, 3, 4, 5, 6 over 1 always, so that's a 6. And then, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 1 always. So the pattern in this case is 2, 6, 10. The pattern for the parent function was 1, 3, 5. This is for the parent function. And remember that the parent function was y equals x squared, where the a is 1. So the pattern was 1, 3, 5. The a in this case is 2. So what did we do to get the pattern? We multiplied each number by 2. So 1 times 2 is 2, 3 times 2 is 6, 5 times 2 is 10. Now what do we do if the a is 3? So what do? We multiply the pattern of the parent function by 3. So 1 times 3 would be 3, so we count upward 3. 3 times 3 is a 9, so from there we would count 9. And then 5 times 3 is 15, we also count upward 15. This is if the a is 3. So once I know what the pattern for the parent function is, and I know what the a is, I can just multiply and find the new pattern. So do I need a table of values next time? No, once you know the pattern, you can just follow it to graph your parabola. Now what's the y-intercept? I cannot see it, so I have to do something to calculate it. We'll talk about that in a minute. Now the x-intercepts are things I can find from my graph. So the x-intercepts are these 2 points. So in this case, they are 3, 0, and 7, 0. Now roots means x equals 3 and x equals 7. I have 2 roots, 2 zeros. Domain is always going to be from negative infinity to infinity. It's opening upward. The range is going to be from the lowest point, which is, in this case, negative 8. And I can always get it from the equation. It's the lowest point, negative 8. All the way up to plus infinity. Now, this is how you can fill this, and this is how you can find the pattern. Now we still have one more thing to find, which is the y-intercept. Now let's take a minute and think about it. What does a y-intercept mean? It's where the graph touches the y-axis. So the x of the y-intercept is always 0. So if I cannot find the y-intercept from the graph, I can go back to the equation, plug in x equals 0, and find what y would be. So go ahead, take a minute and do that. Now 0 minus 5 is negative 5. Now before I can multiply by 2, I have to find what negative 5 to the power 2 is, which is in this case 25. 2 times 25 is 50. Minus 8 is going to be a 42. And that's why I couldn't see the graph or the y-intercept on the graph, because it doesn't go all the way up to 42. So in this case, my y-intercept is going to be 0, 42. Now let's go ahead and move on to another form, which is the factored form. Now let's zoom in to our next example. Now, as you can see, this is the factored form, so I can get the roots from the factored form. The roots are these 2 points. You can set each factor equal to 0 to find the root. So if I set x minus 3 equals to 0, then my first root is going to be 3. And if I set the other factor equal to 0, I will get that my second root is going to be negative 1. So let's plot these 2 points. So negative 1 and 3. These are my x-intercepts. So 3, 0, negative 1, 0. These are also my roots and zeros. So x equals 3 and x equals negative 1 are my roots. Now, how can I find the vertex if I have the roots? Now remember that the vertex is halfway between any 2 points. So if I have the 2x intercept, I know that the vertex is going to be somewhere over here. So I can find the x of the vertex. So 1, 2, 3, 4. Halfway is at 1 over here. And I know that my axis of symmetry is over here. And the vertex is going to be somewhere on the axis of symmetry. X equals 1. So if I know the x of the vertex, how can I find the y? Plug it back in the equation. So if x equals 1, let's plug that in to find the y of the vertex. So go ahead and solve that and find the y of the vertex. Two, negative 2, and then 2. In this case, the y of the vertex is a negative 8. So I knew that the vertex, the x of the vertex, is halfway between the x-intercepts. I plugged that number in my equation, and I found that the y of the vertex, the k, is negative 8. Now, before you graph it, let's find if this is a minimum or a maximum. Now, this is going to be pointing upward since a is positive. So the vertex is going to be the lowest point, so it's a minimum. Let's plot that. So 1, negative 8. Now, let's think of the pattern. The pattern is 1, 3, 5, odd numbers. Now, this is if a is 1, but since a is 2, then the pattern will be multiplied by 2. So the pattern is not 1, 3, 5 anymore, it's 2, 6, 10. So from the vertex, let's count 2, then 6, then 10. So from the vertex, let's count. Did I put the vertex right? No, it's going to be 1 down, so disregard that. So it's going to be up 2 over 1 on both sides. Then up 6, so 1, 2, 3, 4, 5, 6. There you go. It got me to the vertex, or to the x-intercepts. And then from there, you have to count 2, 6, 10, then 10. So up 10 over 1 on both sides. So everything's going to be symmetrical. So there you go. That's my parabola. I hope your parabola looks better than mine. There you go. I don't need a table of values because I can find them using the pattern. Now the y-intercept in this case is something that I can see. So when x equals 0 in this case, y is negative 6. The domain is always negative infinity to infinity, and the range is from bottom to top. So from the k, or the y of the vertex, all the way up to plus infinity. Now I want you to take a minute and try to do the last example on your own. Now this is something in the vertex form, so I can find that a is negative 1, h is negative 5, and since I have no number being added or subtracted on the outside, the k is 0. So my vertex is negative 5, 0. Now a is negative 1. What does that mean? If a is negative, it's going to be pointing downward. In this case, my vertex is going to be the highest point, so that's going to be a maximum, negative 5, 0. Now let's use the pattern. Since a is 1, it means I'm going to be counting downward, 1, 3, and then 5. So from the vertex, count down 1 over 1, and then down 3 over 1, and that would be it. I don't think the 5 will fit in this graph. So it's pointing downward because the a is negative. The vertex is a maximum because it's the highest point. And the pattern is going to be 1, 3, 5, just like the parent function because a is 1, but I will be counting downward. So this is how it looks. Now, what is my x-intercept? In this case, you can see that the x-intercept is at the same time the vertex. So negative 5, 0. So I only have one x-intercept, and I have only one root. Now, how do I find the y-intercept? As you can see, it's not clear on the graph because probably it's somewhere low. So let's plug in x equals 0 in my equation, and let's find what the y would be. If you do that, you'll find that the y-intercept is a negative 25. So 0, negative 25. The domain is negative infinity to infinity, as usual, because it's always going on to the left and right forever. The range is going to be from bottom to top, since it's going on forever down, so it's going to be negative infinity all the way up to the y of the vertex, which is in this case is 0. As you can see, the y is a 0. Now that's all for this lesson. Make sure that you do all the odd numbers in the practice sheet.